complex number a plus bi. Okay? And let's say a is like, I don't know, here. And then bi would be like right here. So this is the complex number a plus bi. And we represent the complex number. Want to see numbers? Let's do numbers. Let's do it. This is easy. Here we go. Alright, so complex numbers equals 3i. To graph this on the complex plane, aka R-GAN diagram. So here we go. It's positive 2, so 1, 2 on the real axis, and positive 3 on the imaginary axis. So there's the. Yeah. Good times. Negative 3, negative 5, no problem. Negative 3 is here. Negative 5 is here. Z. So ridiculously easy. What about z equals negative 4? Yeah, it's just on the x-axis. So 1, 2, 3, 4. There's z. And z equals negative 5. Yeah, just go down 1. That's it. Yay! There's z. Yeah. Alright, here we go. So, as you can see, it's just a point on the xy plane, which means you can do some because you can also do things like find the distance of z, aka the hypotenuse of this rectangle. Right. Yeah. Well, it's still a very find that distance away from the point. Yeah. Right? So find that distance, that radius. That is called the modulus. Repeat that being modulus. Go around saying those smart words. Here we go. Yes. All right. So the absolute value of the complex number is modulus, right? So it does mean absolute value. So you're taking the absolute value of a plus bi. And it's just like vectors, trying to find the magnitude of the vectors. It's the square root of the sum of the squares, right? Just like vectors. So it's a squared plus b squared, right? Vectors, magnitude. So in vectors it's called magnitude, and complex numbers is called modulus. Still an M word. Still an M word. Oh yeah. Here we go. Practice teacher told me I was average. So here we go. Determine. Nope. Okay. Determine the absolute value of each of the following. What? I was just thinking of F word. Here we go. I said I was average. All right. Alright, here we go. So z will be the square root of 5 squared plus 12 squared. Yeah, 169. Oh goodness, this is 13. Yep. And over here, z would be the absolute value of 2 squared plus negative 3 squared, which is square root of 13. Yeah. Joy. All right. Am I going too fast? Good. Okay, so last time we learned that x was r cosine and y is r sine. Okay? A and B are just like x and y. So, to change it from complex to polar, here we go. To change it from complex to polar, pretend your A is your x and your B is your y. So the z can be written as r times cosine plus I sine. So instead of writing r next to each of them, you just GCF that puppy out. Look familiar? Sure. Okay. Where A and B are those things. R, of course, is a squared plus b squared, square root. value of r is called the what was that word? Modulus. Yeah. And the angle between, let me go back to that first picture, right? So you have this angle between right here, theta, right? Between the x-axis and the modulus is called the argument. Yeah, it's the argument. So the angle between that is the argument. Yes. All right. So be able to find the modulus r and the argument theta of all these things. So it's new words, but same. All right, here we go. We're supposed to be on what? Oh yeah, this after Abby. You're thinking about food already. Here's Tim. All right. All right, so plotting z is -1 to -I in complex to write the z in polar form. Okay. Yeah, it's pretty easy. All right. So from this thing, we know that the a is -1 and the b is negative. Yeah. So, I mean, it helps draw math. Here's -1. Here's -√3. Something like that. So your triangle, bam, something like this. Yeah. This right here is r, which is the square root of a squared plus b squared. So -1 squared plus -√3 squared, which is what plus 3? 4 root. So it's 2. Yup. Okay. So that's the r. Now we need theta, the argument. Right? So we know that tan of theta is equal to opposite over adjacent, so b over a. So tan theta is -√3 over -1, which is √3. And you use your handy dandy in a circle. Oh, score power. That's really good. Yeah. 4 pi over 3. Good argument. Yeah. So, to write this in polar form, final answer, z is equal to r, which was 2 parentheses, cosine 4 pi over 3 plus I sine 4 pi. Ta-da! Yay! That's not right, is it? No. You like this? More practice. There's 3 quiz in a row right next to me. Yeah. Yeah, we're getting there. Euler. Yeah. So preview, if you look up what Akia did, e to the ix is another form of polar. Yeah, that's called Euler's. Not Euler, Euler. Swiss or something. Alright. Changing it into rectangular form, it's super easy because it's just r cosine theta plus r sine theta. So if you go ahead and distribute the 4 and then calculate it, so you would have z is equal to 4 cosine 30 plus 4i sine 30, right? Cosine 30 is 3 over 2, so 4 times 3 over 2 plus 4i times 5. Okay? So z is just 2i. Ta-da! So converting backwards and forwards from polar to complex is actually super easy. I'm going too fast. We're good. Okay, so those are the basics. Now let's do some operations. Yeah. Yeah. Here we go. If you want to multiply two complex numbers, right? Basically, all you do is you're multiplying the moduli and adding the arguments. It's like multiply and then add. When it comes to division, divide and then subtract. That's it. That's it. All right. So same pattern. Pretty sure this is in your formula sheet. Yeah. No big deal. All right. Here we go. So for example, if you want to find the product of Z1 times Z2, so Z1 and Z2 will be the two R's multiplied together, so 6 times 5. And then cosine of 40 plus 20 plus I sine of 40 plus 20. Well, how could it be 8? That's 60. Yeah? All right. So 30, oh, we're leaving it in polar form? Fine. Cosine 60 plus I sine 60. And you can stop there because that's polar form. It's kind of basic. Yay? So division, multiply is multiply and add. Division is divide and subtract. So that formula, right? That is polar form, right? Cosine I sine is polar. Yeah. All right. So for division, if you want to go Z1 divided by Z2, you divide the R's. So 50 divided by 5, cosine of 4 pi over 3 minus pi over 3 plus I sine all of that. Yeah? So tan simplify. Yes! It looks so involved there. Tan? Yeah. You do. You just got here. What? Just started. No. You falling asleep? Sorry. Here's some mobs. Oh, man. Alright. So, there's a long, drawn-out process to prove this thing. However, DeMoivre's is actually, it's pretty easy. If you want to find a z to a power, basically, you take r to that power and you multiply the power into the argument. So, here's what I'm talking about, right? By the way, that's not a 2. Change that to an n. My bad. 2 is a power, but you can take it to any power, right? So basically, you drop the power to the r, so it goes r to the n, right? Times, and then you multiply the power into the arguments. So it's cosine n theta plus I sine n theta. This is if you want to take a complex number to a power, which means you can also find the roots of these things, which is going to be so much fun. It's going to happen. You see it? Yeah? Let's practice. Here we go. All right. Take that to the 5th power. So instead of multiplying it by itself 5 times, take the shortcut there. That's just 2 to the times cosine of 5 times 30 plus I sine 5 times 30. Oh, rectangular form? That's easy. 2 to the 5th is 32. Cosine of 5 times 30 is 1/5, right? Okay, so cosine of 150 is plus I times negative a half. Okay. Rectangular is just a plus bi. Oh, what's that? All students in this positive math. Yep. Yep. You guys have heard of all students take calculus? Smart straight class. Yeah. Especially where it's positive stuff. Alright. So this should be 32. Plus 69. Like that, but here's is rectangular. Oh, this is good. All right. So it shows you DeMoivre's theorem for. What was I trying to say? Is that polar? That's polar. Yeah. So let's try doing it for rectangular. Right. If you want to do DeMoivre's theorem for rectangular, now you could just boil that out 4 times. But that's fine. That's fine. All right. Here we go. You need to write that in polar form in order to apply the DeMoivre's theorem. Yeah? To do DeMoivre's theorem, you need the, to do polar form, you need the modulus. So, square root of 1 squared plus 1 squared is the square root of. Alright. And tangent of theta is equal to 1 over 1. Therefore, theta is. Yeah, pi over 4. Thanks, bud. Joy? Okay. So in polar form, it goes root 2 cosine pi over 4 plus I sine pi over 4. And then we're taking that to the 5th power. So z to the 4th power is equal to root 2 to the 4th. Yeah. Cosine 4 times pi over 4 plus I sine 4 times pi over 4. I love that you're guys calculating as it goes. It's awesome. What'd you say? It's 4. 4 times pi over 4 is just pi, right? What's cosine of pi? Negative 1 plus 0, right? Yeah? So the answer is, I mean, do you agree that it's easier than boiling it out like horrible? Oh. We have bad numbers. Oh! Oh yeah, you don't have to do that anymore. Yeah. Oh, but there's the one where you can do binomial theorem too. No. N choose R, blah blah blah. No, it's been a while. Oh, it's been a while. Okay. Yeah. I mean, so if it's not in coordinate or complex, can't change it to polar, then binomial. Yeah. What do you do? Okay. Woo! Alright, so here we go. Probably the most difficult thing. Alright. If you want to take something to the nth root instead, you take the nth root of the modulus, okay? Then you just take the argument, add an entire circle to it, and then divide by that. I know, Lee. It's a good time. It's a good time. Yeah. You don't have to memorize this formula. It will be there for you. Okay? Now, the number of roots has to start at 0. So if you're looking for like the 5th root, then you're looking for the 0, 1, 2, 3, and 4th root. Okay, so k is always n minus 1. So it's, if you're looking for the number of roots, it's minus 1 that root. Start at 0. Okay. All right. Here we go. Find the fourth roots of that and write the roots in polar form with it in degrees. Awesome. Yay. All right. Since we're finding the fourth root, then we're finding k of 0, 1, 2, 3. That's 4 roots. Okay. So in general, zk is equal to the fourth root of 16 times the cosine of 60 plus 360 divided by 16. I should put the k there. Yeah, because we have to apply hk, 0, 1, 2, and 3. Right? Plus I sine 60 plus 360 k divided by 60. Oh, that's 4. Why am I saying 16? I'm silly. That's 4. Thanks, Matt. Bad. So bad. It's over n. Silly flex. All right. So if k was 0, so looking for z of 0, that would be the fourth root of 16 times 60 plus 0 divided by 15. So it's cosine of 15 plus I sine of 15. Joy. Yeah? That's one root. You just polar form, so we're done. That's that. Yeah. So the next k is 1. So it's the fourth root of 16. 60 plus 360 divided by 4. Is it 105 or 115? Oh, okay. Yeah. 420 divided by 4. So it's 405. I must have been like, it's 105. Okay. So it's cosine 105 plus I sine 105. Yeah. Yellow. We're just leaving it. Yeah. It could potentially be because it's such a simple, like that's not a difficult division to make. I don't know. All right. Next root. C2. Fourth root of 16. Cosine of. All right. 360 times 2. What is it? 195. All right. So it's 195 plus. What do you do? Because they're all divisible by 4, right? Absolutely. I was just copying the original formula, so I don't know where it's coming from, but no, you're being efficient. That's the word. Efficient. There you go. Last root. Last root. Z cubed is fourth root of 16 times cosine. What is it? 285. Good on you, mate. Plus I sine. What is it? No, what are you adding every time? It is. That's awesome. Okay. All right. Yeah. Okay. So if it's in polar form, you can stop there. The last one is you gotta write them in rectangular form, which you have to go from polar form to rectangular form. Anyway, let's do it. Yay! Can you insert the word cube roots of 27? The cube roots of 27. Right. The cube of root of 27 is 3, but that's one of them. There are 2 other roots because you have 3 roots of 27. So the other 3 must be in here. Okay. Here we go. So the cube roots of 27 and write them in rectangular form. All right. So ZK is equal to, oh wait, I didn't find the modulus. Sorry. Here we go. Yeah, well, in order to do the formula, it has to be its polar form. Blah, blah, blah. All right. So do you agree that 27 is equal to 27 plus 0i? Yeah? Therefore, the modulus is just 27. Right? It's just the square root of 27. Theta would have to be 0. Yeah, because it's just at the, right? Okay. All right. So using all this to find the cube roots of 27, it would be the cube root, of 27, that's your r, times cosine of 0, what are we doing? Let's do it in radians. Yeah, just to show, plus 2 pi k over 3 plus I sine 0 plus 2 pi k over 3. Woo! That's a squeeze. Oh, we haven't even talked about squeeze there. The cube roots, right? So there's 3 roots. So we're applying k equals 0, 1, and 2. That's it. Okay. Here we go. Z of 0. I'm going too fast. Good. Okay. Cube root of 27 times cosine. 0 plus 0 is 0. Plus I sine 0. Right? Cosine of 0 is 1. I sine of 0 is 0, so the cube root of 27 is just 3. That's why that's the 1. Some of the real ones. Hey, that is! Good times! Good times! Okay. Alright. Z1. Find the other roots. Cube root of 27 is cosine of, alright. What is it? It's just 2 pi over 3. Yeah. Plus I sine 2 pi over 3. Cosine of 2 pi over 3 is 1 half. What is it? Negative 1 half? Yes. Negative 1 half plus sine would be 3 over 2, right? Is that right? 2/3 is in the second quadrant, sine is positive, blah, blah, blah. Okay. Cube root of 27 is 3, so 3 times 3 1 half is negative 3 over 2, right? Plus Alright. Alright. Last one. Okay. Cube root of 27. Cosine. 4 pi plus I sine 4 pi over 3. Right? 4 pi over 3 is negative square root of 3 over 2 and negative a half. Is that right? Okay. So multiply those by 3. Get it. I mean, what do you think? Is joy? Is joy. Alright. Houston, if you're watching this, it's not that bad. Here we go. Your homework tonight. Can I move it? Alright, is not the entire worksheet, it's the multiples of 3. So make sure you write that at the top. The multiples of the red. Okay? Do you know be all of 24 seconds. Oh.